Hi, this is Calvin Tian, a former student of this course, and I'm so glad to be invited to give a short description about this course. So what you're going to hear in the next several minutes are going to include what you're going to learn from this course, how you're going to benefit from it, and what are the prerequisites. Let's jump into the big picture. To determine the internal forces and moments, there are generally three methods. There are force method, the displacement method, which is also in this course called stiffness matrix method, and then the reduction method. In this course, you're going to be introduced to this matrix method, and as an extension, you'll be learning the finite element method. To apply the FEM method, you will have to know and get familiar with the concepts of 1D, 2D, and 3D elements in FEM. So by the end of this course, you guys are expected to gain a better and concrete understanding of the structures, and I guess this is a very good start point to be an expert. So you might ask, what is so good about stiffness matrix method? Let's look at an example. On the left-hand side, you're looking at the structure with some external forces, and you're asked to plot the shear force diagram and bending moment diagram. I know the first thing that comes to your mind would probably be the force and moment equilibrium equations. However, that method is very computational unfriendly, because if you're using those equations, you're generally solving for one beam every time, and it's very specified and takes a lot of time, especially when you're dealing with some indeterminate structure. That is a big problem because you have more unknown parameters than your non-equations, and that just can't be used, that method, right? All right, so on the right-hand side, you're given the formation of the matrix analysis. You know, it looks like force equals to the material properties, whatever, like steel or timber, right? And then displacement. Well, this method enables you to solve the entire structure very quickly because it just put everything in this matrix. And also because of the application of the matrix, it is more generalized. And that means, for instance, if you want to change the coordination of a system, you just multiply it by a transformation matrix. That's very easy and generalized, right? Well, and then you're going to be introduced to finite element method, which is also termed as FEM. So in this method, the first step is really to divide a structure into several elements, and then apply the displacement method on it to get a highly accurate result. It is a more substantial method because you usually have some cross-section parameters, and it's just more specified. It is the mechanism of software packages like Abacus and ANSYS. We're going to talk about that later. And in this course, you're going to learn what is a good discretization, and this is just a fancy word to describe how to divide those elements. First important thing you're going to know, okay, how many segments are enough? And then you're going to learn how to make a good choice of member function. So the member function we're talking about here is related to the element directly. What you can see here, like 1D and 2D, those edges here are functions. And in this course, you're going to perform the hand calculation of 1D and 2D elements. For 3D elements, we're going to leave it to the computers. So talking about prerequisite, those marked in red are units that I suggest you to take before taking this unit, especially engineering mathematics and mechanics solids. You're going to need a lot of knowledge from it. And then marked in green and red are the units that you probably benefit from taking this course. To be specific about math, you will need to know some knowledge from calculus, and that includes differentiation and integration. In terms of differentiation, you will have to know the partial derivative, the chain rule, and because matrix analysis plays a very important role in this course, you will need to know all aspects of matrix manipulation. And that includes sum, subtraction, product, inverse, and transposition. The lecture is going to be delivered in a style demonstrated in the picture on the left. And the lecture will write something in the paper, and the paper is scanned by a scanner. The talking speed of the lecture is not too fast, so I think it's very easy to follow. The tutorials will follow materials that is delivered in the lectures, and I reckon like 6 weeks for the matrix analysis, and then 3 to 4 weeks for finite element analysis, and that includes the computer lab, which will build up skills about Abacus, the software package. If you have any questions, just ask those tutors. They're really helpful. So talking about abacus, in the last session, the lecturer told us that it's very good to list your CV if you have some abacus or finite element method skills. And it's actually the truth because I have done some experiment. So here, if I type abacus in LinkedIn search tab, 2,000 results will pop up. And that includes the software development company, the structure company, and the research institution. From my experience, there should also be some geotechnical engineering companies that require the knowledge of abacus. Alright, so the other benefit of abacus is that it's very versatile compared to most dedicated mechanical software packages. Well, that means not only the mechanical engineers can use it, the civil engineers can use it too. So talking about automation, that's my favorite part about abacus. After taking this unit, I have learned to use the Python to manipulate the abacus, the software, to replace some repetitive work. Some study suggestions are listed here. Make good use of the abacus documentation when you're learning it. Take advantage of the Moodle practice classes, that means the worksheets, some Moodle reading materials. Those are really important in your comprehension, and I would better recommend you to download the MATLAB Student Edition. So you guys might also heard that besides the midterm test and final test, there's also be a project that takes up a relatively high score in your continuous assessment. So I would like to share some of my cases, which is really interesting from last session. What you're looking at here is a building under normal condition load, which is the dead load and live load. And then you're using abacus to simulate the building on the fire on the third floor. And then you're looking at a building responding to the blasting at the ground floor. So those are really interesting and practical cases that we have done in the last session, and I just wish you really good luck and have fun in this course. Thank you for listening.